so just so we understand, there was two things going on. The first 1 through 11 was just graph those parabolas, shade in the right area. Okay? The way the shading works, or the way it should work, is you pick a point not on the parabola as your test point. Okay? And then you plug that in your original inequality, and it either gives you a true statement or a false statement. If it gets you a true statement, you shade there, wherever that point is, either inside or outside. If it's a false statement, you don't shade there, you shade the other part. Is that okay? All right? So then, this part was just strictly solving. So there's two things. On the just graphing, the vertex is pretty important. And then, like if you watch the video, I said, well, you only really need two other points. I would pick where it crosses the y-axis and its reflection. And that's enough. There's graphed, and you can shade. On this, the important part is the x-intercepts, because that's what we're going to do. We're going to answer with our x values. Okay? So I'm going to go through it the way I explained it, and then I'm going to add a little bit to it so that you have another way to think about it. So if we're finding x-intercepts, what has to happen in that process? Not the 10. We'll deal with those here in a second. No matter what, if you're finding, no matter what, if you're finding x-intercepts, you got to have it set equal to 0. Then you can choose your options. So I'm going to subtract 5. And now what are your options from this point? What are our options from this point? Because really, this can be equal to right now, but so as in, how do you find x-intercepts? You got a bunch of options.
Yeah, you do the quadratic formula.
That works every time. You can do that every single time. Be done with it. Never have to worry about it.
Plug it into a calculator.
Only problem with that is if you're asked for exact answers, you may not get it. But you may not get it if they want exact answers. So you can factor it. Those really should be your only two options. Okay? You never have to think of factoring, but if you're averagely good at factoring, it's way, way quicker. Okay? Now, this is obnoxious because of the 3/4, right? But you can just go into the quadratic formula and go from there right now. Factoring, that's a little bit more work. But we have an inequality, which is kind of the same as an equation. So what I would say, and I don't want to mess with fractions even in the quadratic formula, I would say, well, look, there is a number that I can multiply all this by, and then I won't have any more fractions. What would that be? Okay, so eventually we're going to do that, but just to get rid of the fraction, how about just 4? Okay, so 4/3 would be great, and that's kind of what we're going to do. But like, we can just do that. So then what's 3/4 times 4?
12.
Which reduces to 3x squared. So then, of course, that's going to be 3x. And then what's 4 times? Negative 60. Okay, and then we're really multiplying it by that 0, but it's 0. And then since we're going in this route, 3 goes into all these. So, you said 4/3, which would be great. I'm going to divide now everything by 3. So you got a little bit of room when you got it two sides. So really, we can get the same information by messing with this. Now I'm going to change it to equal right now. So then this will get us the same x-intercepts as the original. Quadratic formula is great. This one factors. So I'm going to factor it. So 1 times negative 20 is negative 20. Factors of negative 20 that add to give you positive 1. -4 and +5. Okay. Now, if you're factoring, you're not quite done, right? You got to set these equal to 0. Add 4 there. Subtract 5 there. And so those are where this crosses the x-axis. Okay, so now remember, we're really dealing with, right, this inequality. Okay, so then these are going to be important, but really what we have is this. All right, so again, a little bit different. I don't care where the vertex really is because I'm just wanting to answer in x values. But I do know that there's an x-intercept right here. And I know that there's one right here. And why do I know it opens up?
It's greater.
Not because of that.
That's not negative.
What's not negative?
The x squared, 3x squared.
Yeah, so it's a positive, so I know it's going to open up. Okay, and this is really the only thing I'm really concerned about right now. So is that okay with everyone? Well, I guess it should be a dotted line. Sorry, I'll put it as a dotted line. Why is it dotted?
Because it's not equal to.
It's not equal to also. Okay, so if you watch the video, right, like if you flip back to page 192, that bottom, they had all these different options going on. Like if this is greater, and then this is greater, and then, right, and that's just too much. Okay, so I tried to simplify it down a little bit, which was if, and I'm going to look at, let me do this. So I'm looking at this one here. So what I said is if A is not positive 1 or positive anything, multiply everything by a negative to make it positive. If you do that, this would have to flip the other way. Okay? Then, once that's true, then you're just looking at this. This will be an or. If it was flipped around the other way, it would be an and. Okay, so ors are going out. Ands are going in. Okay, so we've manipulated it to make it do the same thing every time. Okay, so since it's this way, it's going to be an or. It has everything to do with these two here. And so then what I'm saying is an or would go this way and it would go this way. Is that okay? And so then you can say, okay, well then my solution is going to be, they keep doing this, x such that x has to be less than -5 or greater than 4. All right, so here's another way to think about this. Now, firstly, is there any questions about that? Okay.
That's the answer right there.
So this is the answer down here. And this is how we went about it. Okay.
That's how we're gonna write it.
This is how they want you to write it. Yeah. Okay.
With the brackets and everything.
Yeah. And that part, like, if you're not sure about it, like, ask and I'll help you with that part. Hopefully, it's starting to look more and more familiar. And this line is such that I have no idea why. Well, I have no idea why. Okay, so like to me, like this is like the same thing. I don't know why we have to do that. I don't know. But somewhere along the line, someone was like, "That's a cool way to do it." I don't know. The squiggly brackets are sets, and so then the set makes sense. I don't know why we do the x such that. I don't know why we. Yeah, I have no idea about that at all. Okay, so here's the other way that you can think about it. Can you accept that this or this is a function?
This or what?
Like this one here?
Yeah.
Or like this is just, can we accept that that's a function? And then can we accept that functions are really y values? Okay? And so then would it be okay to say that these y values that we want better be positive? Because it's greater than 0. Is that an okay thing to say? All right? So if you can think through that and saying, well, all of our answers are going to be where the y values are positive. Well, where are the y values positive? On a graph.
The right side.
Yeah, up, right, in the above the x-axis, right? So can we also then say, okay, well look, that makes, what happened there? That makes these an answer, or where the answers come, and also these, because those lie above the x-axis. And so then if all of that's okay, you can say, well, where does that happen? And that's an x question. Well, all that happens when x is greater than 4, or it happens where x is less than -4, or I'm sorry, -5. So that's another way to think about it. Is that okay?
So then, shading wise, where would you shade?
So yeah, so then where would we shade? So just like if it was like these first couple problems, you could pick a 0, 0 point, okay? And this is all connected. So we could pick 0, 0, which is what you always should be picking. And so then we could plug it in here and here, or maybe even easier here. And then you'd be asking yourself, is -20 greater than 0? No, so don't shade here, right? You would shade like out. And again, that still matches up with the fact that we're going in this direction and in this direction. Is that okay?
Yeah.
All right, so remind me that I got to press pause. All right, so then, what happened? Oh, you got it. It's not on mine anymore. What happened to it? There it is. All right, here we go. All right, so now let's get back on page 194. All right, we're going to look at Marcus. Marcus is planting a garden. He has enough soil to cover 104 square feet, that is, and wants the dimensions of the garden to be at least 5 feet by 10 feet. If he wants to increase the length and the width by the same number of feet, by what value can he increase the dimensions of the garden without needing to buy more soil? All right. So right here's his original. It's 5 by 10. He's going to increase. How do you find the area of that? Yeah, equals area. So times you multiply, right? But that's not what he wants to make it bigger by the same amount. So he's going to add something to both sides. Okay, and then find the area, and then that's how we get this. Is that okay?
Yeah.
Is that okay with everyone? Whenever you can draw a picture, you should draw a picture. It makes more sense that way. All right, so then they say FOIL. So when we FOIL this, what do we get?
X squared plus 5x. And then 10x plus 50.
Okay, and so then what's missing? 15x. Is that okay with everyone? Right, we just found the area of this Marcus's new garden. Okay, and then they say the area must be less than or equal to 104 square feet because he doesn't want to buy any more. So then this is going to be 104. All right, all we're doing is solving for x. So now you guys can do it any way you want. I'm going to do it the way the book is. Okay? But we're just finding x-intercepts of this parabola. So that means you always have to do what first?
Make it equal to 0.
You got to make it equal to 0. So then we're going to subtract 104 over. So 50 minus 104 is negative 56. Right? You can do the quadratic formula from here if you want. Right? They say it factors. So factors of negative 56 to add to give you 15.
Shoot.
7 and 8 gets you 56, but they don't add. One of them has to be negative. Right? Because it's negative 56. Yeah. But they won't add together to give you 15 anymore. I mean, they gave you a hint up there. I mean.
-8. Oh, and 3.
All right, well,
18 and 3.
well, it's going to be opposite though. So it's going to be positive 18 and 3. It factors into that. You guys can do it. Right, but it has to be that way because positive 18 plus a negative 3 is positive 15. And so then how do they get negative 18 and 3? Because you got to set these equal to 0. Right, subtract 18.
Boom, baby.
Is that okay? So what the next part is saying is that you don't need to graph this. All we need is a number line and to test some points. So it's like we took our coordinate plane and just hacked off the y's and just looking at the x's now. Okay, and so then if these are our solutions, then they're saying this number line is now broken into 3 parts. Right, here's negative 18, here's 3. So we're either less than negative 18, or we're greater than 3, or we're somewhere in between. And now all we're going to do is take some points and test them to see if we get true or false statements. When you get to pick testing things, you should always pick easy ones if you can. So never pick the endpoints, or as in like don't pick negative 18 and 3. Okay, but if you can pick 0, that's super easy to work with. 1 is super easy to work with. Any multiple of 10 is super easy to work with. But you just got to pick 1 in each of these spots. So they're saying, all right, look, we're going to test out negative 20, which gets us less than 18. You pick 0 because you can pick 0 for the in-between one. I would have picked 10, but they picked 5. Okay, now we're going to test each of those, and we're going to test them into the inequality right here. All right, so we'll just start on the left. So then negative 20 squared plus 15, that's supposed to be a plus, why is it not working? Plus 15 times 20 plus 50. So what's negative 20 squared? 400. What's 15 times 20? Close.
14?
I think that's 14 times, yeah.
No, 300.
So 300 then, yeah.
I did that in my head.
I saw you get up.
No, I was testing my mouth.
That's pretty good.
All day in the mouth.
Yeah, that's pretty good, yeah. All right, so then now the question is if we add all those up, is that going to be less than 104 like it's supposed to be?
No.
No. Okay, so then none of these work. Okay? So now let's pick the 0. That's it. We're in between now. All right, same inequality that we're testing in. 0 squared plus 15 times 0 plus 50. Is that going to be less than 104?
Yes.
Yeah, okay, so then we know so far that at least there's going to be some solutions. We want to make sure that's the only way, so then we take 5, we square it, multiply 5 and 15, add 50. So that's 25 plus 75 plus 50. Is that going to be less than 104? No. All right, so our only solutions are right there in between negative 18 and 3. Okay, and so then what they're saying on this next sentence is the only value that satisfies the original inequality from the 3 that we chose is 0. And that makes the solution set from negative 18 to 3. Now this is some more of this notation stuff. These brackets, right? This is like a interval from negative 18 to 3. The square brackets say that negative 18 and 3 are also possibilities. So far, so good? If they were rounded brackets, negative 18 and 3 wouldn't work. But everything in between them would. All right, so Marcus can increase the length and width up to how much without needing to buy more soil? Up to 3 feet. But they also point out, hey, by the way, he wants to increase, so none of these negatives are going to make any sense. He doesn't want to decrease it, so we're going to stick with, the negative 18. These numbers here, we're just going to ignore. Is that okay? All right, so that's the new stuff. That takes care of everything. You can now get to 39. So is there any questions on any of this? All right, so